In this video, let's talk about clustering and data mining. Imagine that you are a director of customer relationships and you have 3 managers working for you. You would like to organize all the company's customers into 3 groups so that each group can be assigned to a different manager. You would like that the customers in each group are as similar as possible, and 2 customers who are very different in business patterns should not be placed in the same group. So how are you going to group these customers who are similar to each other based on the data? You need to discover these groupings based on the data attributes that define the customer profile. Unlike classification, the class label of each customer is unknown. This is where clustering can help. Provided we don't have the class label, clustering is an unsupervised method. Clustering is the process of grouping a set of data objects into multiple groups or clusters so that the objects within the clusters have high similarity but are very dissimilar to objects in other clusters. There are many applications for clustering, such as customer segmentation, image classification, and anomaly detection. Clustering can help identify patterns and relationships in data that may not be immediately apparent, and can provide valuable insights for the business and scientific research. Simply put, cluster analysis or clustering is the process of partitioning a set of data objects into subsets. Each subset is called a cluster, and the objects in a cluster are similar to one another and dissimilar to objects in other clusters. There are different approaches for clustering. Let's talk about the most commonly used, that is k-means clustering. K-means clustering is an algorithm that is used to partition a set of data points into a specified number of clusters. That is to say that we want to identify k number of clusters. Let's look into the steps for k-means clustering. We start with selecting the number of clusters that we want to create. The second step is initializing the clusters, that is selecting random k data points which act as the initial cluster center. Step 3 is measuring the distance between data points and the initial cluster. For each data point, we calculate the Euclidean distance to the cluster center. Step 4 is assigning the closest data point to the nearest cluster. Step 5 is calculating the mean of each cluster to change the cluster center, and repeating steps 3 and 4 until the clusters stabilize. That means the assignments don't change in the next iterations. What are the different distance measures that can be used for clustering? Distance measures are used in clustering algorithms to measure the similarity between objects. Like we saw in k-means clustering, Euclidean distance is used. Euclidean distance is the most commonly used distance measure and is defined as the square root of the sum of squares of the difference between the coordinates of the 2 points. It is often used for continuous numeric data and is suitable for data with linear relationship. Manhattan distance is also known as taxi cab distance. It is defined as the sum of the absolute differences between the coordinates of the 2 points. It is often used for categorical or binary data and is suitable for data with a non-linear relationship. Cosine similarity is a measure of the angle between 2 vectors. It is often used for text data and is suitable for data that is represented as a sparse matrix. Jagged similarity is a measure of the overlap between 2 sets. It is defined as the size of intersection of the 2 sets divided by the size of the union of the 2 sets. It is often used for categorical data and is suitable for data that can be represented as a binary matrix. So once we have created all the clusters, how do you evaluate it? There are internal and external methods that can be used for evaluation. Internal evaluation methods involve assessing the quality of the clusters based on the characteristics of the objects within each cluster. compactness. Compact clusters are those that have data objects that are close together, while dispersed clusters have objects that are far apart. Compact clusters are considered to be of higher quality. The next measure is separation. When the distance between cluster centers is large, it is said to be well-separated clusters, whereas clusters that have small distance between their centers are known as poorly separated. Clusters with good separation are generally considered to be of higher quality. The third measure is silhouette coefficient. It is a similarity metric that measures the degree to which an object is similar to the other object in its own cluster compared to other clusters. A high silhouette coefficient indicates that the object is well matched to its own cluster and the clusters are well separated. Internal evaluation methods involve comparing the clustering solution to a known ground truth or to a different clustering solution. Adjusted rand index measures the degree of overlap between two clustering solutions. A high adjusted rand index indicates that the two solutions are similar. F measure is the measure of precision and recall of a clustering solution. It is calculated as the harmonic mean of precision and recall, and with a high value indicating a better clustering solution. Mutual information measures the degree of mutual dependence between two clustering solutions. A high mutual information indicates that the two solutions are similar. It is important to keep in mind that no single evaluation measure is perfect, and depending on the characteristics and goals of the analysis, multiple solutions could be used. Hence, it's generally a good idea to use a combination of evaluation measures to get a well-rounded view of quality of the overall clustering solution.